Hey everyone, in this video we'll be going over how to prove trig identities and how to simplify trig equations. Now before you can simplify trig equations, such as number 1, you have to know a couple rules that you have to follow in order to simplify them, because this is entirely just based on rules and there's no actual math here. So these rules are these are the properties of trig functions. So there are only a couple that are really important. So firstly, we have our quotient properties, which are tan x is equal to sine x over cos x, which is also equal to secant x over cosecant x. Next, we have cot x, which is equal to cos x over sine x, and then it is cosecant x over secant x. So these are our quotient properties. Next, we have our reciprocal properties, which you might already know these, but it's just cot x is also equal to 1 over tan x, and then secant x is equal to 1 over cos x, and then cosecant x is equal to 1 over sine x. Now these can be rearranged depending on your equation. So you can rearrange it so that way it's tan x is equal to 1 over cot x. So it's just depending on what your equation is asking. And lastly, and probably the most important, would be your Pythagorean properties. So the first Pythagorean property would be cos squared x plus sine squared x is equal to 1. And then our second one would be 1 plus tan squared x is equal to secant squared x. And then finally we have cot squared x plus 1 is equal to cosecant squared x. Now, these can clearly be reorganized. So if you're trying to solve for cos squared x, you can reorganize it so that way it's cos squared x is equal to 1 minus sine squared x. And it can be applied for all three of these. Now, what you might notice is different about the final Pythagorean properties would be that they have squares. So that is similar to the a squared plus b squared equals c squared formula that you're used to. But in this case, it's just trig functions. So it's cos squared x plus sine squared x and stuff like that. Now, what you might notice is different about these final Pythagorean properties is that they're all squared. So that's really important because in your equation, you have to be careful not to use a normal cos x or sine x and assume it's a Pythagorean identity. You can only use this Pythagorean properties when it's squared. So be really careful of that when you're solving. So these are the three main ones to prove trig identities and simplify them. And there are a couple more, but these are the main ones. So let's go ahead and move on to our problems here. We'll start with number 1. So we have sec x times sec x minus cos x is equal to tan squared x. Now, this tan squared x is basically just a final proving point. So our problem itself is just proving this section. We're just proving the left side of the equation. And we can reinforce that proving if we get tan squared x in the end. So we can say, definitely, yes, we did the correct method of simplifying. So if we're just taking the left-hand side of the equation, let's rewrite this. So we have sec x times sec x minus cos x. So now, our first step would be to break down the sec x inside of the equation. So inside of the parentheses. So when you see that's two functions inside the parentheses, you want to try and see if it can be reorganized to make them like terms. So let's just make this new equation into sec x times 1 over cos x minus cos x over 1. Now, as you can see, I simplified the sec x into 1 over cos x because that's from our properties in blue here. So sec x equals 1 over cos x. And then I just put the minus cos x over 1 just to make it a little easier to understand. So then our next step would be, let's make those like terms. So let's bring that cos x over to the bottom. And if we do something to the bottom, we also have to do it to the top. So then we end up with sec x times 1 over cos x minus cos squared x over cos x. So now that we have this equation, let's go ahead and add like terms. So this will become sec x over 1 minus cos squared x over cos x. Now what you might notice from the top, on the top of the inside of that parenthesis fraction, is that is a squared function, so it's a Pythagorean property. So let's go ahead and look at our Pythagorean properties here at the bottom in green. So we have cos squared x plus sine squared x equals 1. Now if we rearrange that and we bring that cos to the other side, we have sine squared x is equal to 1 minus cos x. So down here, if we were to take cos squared x and bring it over to the other side here, we have sine squared x equals 1 minus cos squared x, and that is our exact formula that we have over here. So let's go ahead and break that down. So we have sec x, so we have sec x times sine squared x over cos x, and then this is equal to 1 over cos x times sine squared x over cos x, because we just took that sec x and made it into 1 over cos x. That's one of our properties. And then we just combined it right across because it's multiplication, which is equal to sine squared x over cos squared x. And now that would simplify into tan squared x. Now you might notice that sine squared x over cos squared x isn't one of our properties that we have listed, but when there's squared on the numerator and the denominator here in this scenario, you can assume that it's just sine x divided by cos x, and which is one of our properties, which is equal to, as you can see up top here, which is equal to tan x. And we can't forget those squares, so we can just make it tan squared x instead of tan x. So that is how you solve the first problem. So I'll go ahead and erase this, and we can do the second one as well. So our second problem is tan x times cot x plus tan x is equal to sec squared x. Now, similar to the first one, our right side of the equation, we're proving the right side of the equation by simplifying the left side of the equation. So from tan x times cot x plus tan x, we will get sec squared x. So we're basically just simplifying this guy. Now let's go ahead and write this out really quick. So tan x times cot x plus tan x. Now the first step we would take is try and see if we can take like terms from the functions inside the parentheses, similar to how we did in the last one. And this one we get tan x times 1 over tan x, which is one of our properties, plus tan x. And that tan x right here is over 1, just in case that makes it easier. So then we have tan x times 1 plus tan squared x over tan x. And I got that by multiplying this bottom by tan x and multiplying the top by tan x. Now, after you multiply and then you combine like terms, since the denominators are the same, you can combine them. So you'll just get 1 plus tan squared x over tan x. And all that is multiplied by tan x. So 1 plus tan squared x, as you can see on the bottom here in green, is one of our properties, 1 plus tan squared x, and that is equal to sec squared x. So let's write that out. We have a new equation, which is tan x times sec squared x, so that's secant squared x, over tan x. Now, one lucky part about this equation is that this tan x and this bottom tan x cancel out, and then we are left with sec squared x. And now that can be simplified further into 1 plus tan squared x, but for this one, we're just proving the right side of the equation, and the right side of the equation is sec squared x, so that will be our final answer. So this is our method of simplification. And in the next video, we'll be going over numbers 3, 4, and 5.